We were doing chapter 3. Or did we finish chapter 3?
Yep.
Yeah, we finished chapter 3.
We're on page 47
Awesome. We
still.
were doing vector algebra. Fantastic. I think I have a couple more on page 47 to finish up. So let's do that. And then we'll move on to chapter 4. So we were doing these vector algebras. And we were doing, I think we got to A dot C cross B, and we didn't finish that. So A dot C cross B is going to be a determinant which has A in it in the first row, 2, 4, negative 3. Second row is C, which is 1/3, negative 1, 0K. And the last row is B, 9, 0, 3K. You extend the next two columns out if you're doing it by hand, or if you're doing it by your calculator, make sure that I see the determinant. Because if I don't see the determinant and you just give me an answer, I'm going to assume you cheated. Or what happens is you don't give me the determinant and you get the wrong answer. I can't sit there and say, was it a math error? Did you forget a minus sign? Do you know what you're really doing? I don't know. At least if you give it a determinant, I know that you know it is a determinant. Now the answer might be wrong, but it might be just a math error, and I can live with that. So the answer to this is minus 37. Okay? Angle between A and B. That goes back to the definition of the dot product. Cosine inverse of A dot B. Divide by magnitude of A, magnitude of B. Well, I've already done A dot B. It's the very first one. The answer is 9. So this is really cosine inverse of 9 divided by the magnitude of A and B, 5.385 times 9.486. Square, square, square out of there, take the square root, you have the magnitude. You do the cosine inverse of this, and you're going to get 79.85 degrees. What?
Then we go back to D. I have a question.
You go where?
Question D with the determinant.
Yeah.
Is it possible, would it still work if I could determine with IJK and then not positive that with
Yes. That's fine. But you're doing it in 2 steps, I'm doing it in 1. All right, component of A parallel to B. What is this really saying? Project A onto B. That's what it says. That's what it's saying. And in other words, if I interpret what it says, that's what it's telling me. Hey, project A onto B. Same as find the component of A parallel to B. So I can sit there and say A parallel is equal to A dotted with unit vector B. How do I project any vector onto another line or vector? Find the unit vector of the line you're trying to project onto, dotted with the vector you're trying to project. I'm trying to project A onto B, so therefore I need the unit vector of B. Well, that's easy. That's going to be 2I plus 4J minus 3K dotted with B, which is 9I plus 0J plus 3K. Divide this by the magnitude of B, which is 9.486. Should I get a vector or a scalar here? Huh? I should get a scalar. I'll get a number. That number is 0.9488. 0.9488. Component of A perpendicular to B. Well, really what you're saying is, hey, I have this vector A. This angle is theta. This component is going to be A parallel. This component is A perpendicular. So the perpendicular component is your Y, and your A parallel is your X component. Well, one of the ways I can do this is A perpendicular is equal to the square root of A quantity squared minus A parallel squared. What the hell is that? That's nothing more than the Pythagorean theorem. Not the Pythagorean, yeah. A squared plus B squared equals C squared. Right? Just rearrange to find A perpendicular. That's going to be the square root of A. A is 5.385 quantity squared minus 0.9488 quantity squared. That'll be 5.3. Another way of doing that is to say, hey, A perpendicular is A sine of theta, the angle in between. A is 5.385. Sine of the angle in between, we know the angle between A and B is 79.85 degrees. That's still 5.3. So either way you slice it, dice it, mince it, whatever, you're going to get 5.3. So this is nothing more than C squared equals A squared plus B squared. So I'm saying C squared equals A squared plus B squared, and I'm rearranging for B. B is the square root of C squared minus A squared. That is what you see here. Okay? Questions? Question? You're a happy camper so far. Until I spank you on the test. Huh? Am I going to spank you on the test? What? All right. Carpenter, you good? Carpenter's great. She's not good. What? I can do anything. You know why? Because I believe in myself. I'm a what? I'm not a God. I just believe in myself. And those of you that don't believe in yourself, you're not going to be successful if you don't believe in yourself. I got my first job teaching. I never taught in my life. But I said, yeah, I can fucking do it. I lied through my teeth. But I got the job. And I got it done. Why? Because I believe I can do whatever I put my mind to it. It's that simple. You guys gotta believe that. Piece of cake. Don't ever say, I can't. That word does not exist in my vocabulary. It just, I refuse to accept I can't. It's not going to happen. No way in hell will I accept I can't in my vocabulary. Not possible. And you shouldn't either. Oh, I don't know if I can get an A. Why not? Sure you can. But the question is, did you work hard enough to get an A? Well, if you did, then you'll probably get an A. If you did, you ain't gonna get close to getting an A. What was your question? You can. That's exactly what he asked me. I said the first letter is A. I put all the values of A in the first row. C is the second letter. I put that in the second row. And the third row is B. And I did a 3x3 determinant, where I extended the first two columns over in red, and then I did the diagonals. That's all I did. Nothing fancy. Yeah, you add up all the numbers. Do I really have to do the work? Oh my Lord. Oh my Lord. You guys killed me. 2, 4, -3. 1/3, -1, 0. 9, 0, 3. I'm going to extend the next two columns over. The first two, 2, 4, 1/3, -1, 9, 0. I'm going to do this. That's -6. I'm going to do this plus 0. I'm going to do this plus 0. I'm going to do this. I'm going the other way, so it's a negative. 1/3 times 3 is 1 times 4 is 4. So I'm doing this way now. This is 0. This is -27. Negative is a positive, but since I'm going that way, I add another negative. So -6, -27, -4. That gives me -37. Okay? Now you're asking me to do shit that's math oriented. It's not got nothing to do with fucking status. Nothing. Okay? Alright, how many saw the video on moments? What?
This is off topic. When I'm wearing your office hours?
Mondays and Wednesdays, 11 to 12:30. And usually afternoons, probably 3:30 to 4:30ish. Somewhere in there. Or whenever you can find me in my office. If I'm not in class, I'm in probably my office or at lunch.
Where is your office?
Fuck, it's been 3 weeks and now you're asking me where my office is?
I've been looking on the campus and I just can't find it anywhere. I've been asking around with you.
It's a secret.
Third?
I'm on the 3rd floor of ENC in the civil engineering office suite. The suite. Yeah, there's a suite. S-U-I-T-E. Suite. Not S-W-E-E-T. Sweet. Sweet. All right, so let's move on to moments. This is the first time that we're changing the model of reality. Everything we've done in chapter 2 and 3 has been particle. So we have to change the model to rigid body. Why do I have to change the model? Because this is the first chapter I'm trying to introduce moments. In order to have a moment, as you read in the first 8 pages, is force times distance. And you have to have a distance in order to create a moment. Well, in chapter 2 and chapter 3, there were no distances, there were particles. Everything came to a concurrent point. Now, things don't have to come to a concurrent point. So I have to change the model to a rigid body. Well, if you read the first 8 pages, you know what a rigid body is. It's a system of particles in which the distance between any two particles does not change length. That can't expand and it can't shrink. So I have size, I have center of gravity, I have dimensions. I cannot have deformation. So things can't deform. Everything deforms. But we're saying our model is not allowing deformation. That's why you have to go to the next class, whether you're mechanical or civil. Go to the next class, EML 3500 for mechanicals, mechanics of solids. or EGM 3331 for civils, that's where everything starts to deform. It's the first time you'll see deformation, and if you think this class is hard, that one's worse. Okay? Once you get to that class, you're going to say, why did I think statics was hard? Because this would be baby cadence. Alright, so forces need not be concurrent. Remember that. Alright, so the reason we're in this chapter, the very first part of the chapter, talked about cross products and the definition of a moment, which we define in the first 8 pages of the Pro Copy booklet, which is the tendency of force to cause a rotation about a point or axis. How do we calculate it mathematically? R cross F. Well, that's why we spent a little time on vector algebra to discuss how do you calculate a cross product. So everybody knows how to calculate a cross product, so you should be able to calculate a moment if I gave it to you. And remember, we said this is the vector C is equal to A cross B. We said C was perpendicular to the plane that contains A and B. So this moment is perpendicular to the plane that contains R and F. How do I calculate it? Well, we discussed that already. We said R cross F is nothing more than the determinant. First row ijk, second row rx, ry, rz. Third row is the next letter, which is fx, fy, fz. So R is in its component form, F is in component form. What's R? Well, that's the position vector you learned back in chapter 2, section 7. xb minus xa, yb minus ya, zb minus za. Rx is the component of the x's the difference of the x's. The difference of the y's is ry, and the difference of the z's is rz. Notice when you do the cross product, you get this. Now, do I want you to memorize that? No. I do want you to see that there is no x component of r or f in the I. There is no y component in the j, and there is no z's in the k. That's what I want you to know. That's why I put it there, so you can see that. Just like forces have components, so do moments, because they're vectors. So this ryfz minus rzfy, that is the mx component, just like you had the fx component. This is your my component, just like you had your fy component, and that's your mz. Now, technically, I need to draw these little curls to indicate a moment. Hard to do. It's easier because the book has got a publishing unit to do all that nice drawing. I don't have that, so I have said, hey, when you're talking about moments, I'm going to show a double arrow. So you'll see me draw double arrows to indicate moments. What's the double arrow mean? Well, if this is the MZ coming out at you, I'm going to put my thumb on the double arrow, which is coming out at you, and then curl my fingers on the right hand. That tells me that's the moment. If I'm looking at the Y, I'm going to put my thumb there, and I'm going to curl my fingers around that axis. Here, same thing. I'm going to curl my fingers that way. That tells you the rotation of the moment. Got it? I've already stated this. Most important, number 4. Hey, what does number 4 say? R is the position vector from the moment center. There's always going to be a moment center, because I'm going to say, hey, find me the moment about, that's your moment center. A, B, C, O, whatever. Notice it's a position vector from the moment center to, very important, any point on the line of action of the force. Usually you go from the moment center to the tip of the vector or to the tail. Why? Because usually you know coordinates about the tip and the tail. But can I go anywhere in between? Absolutely. So I'm looking at this force here, and I say, I want you to find me the moment about the origin. Well, I can take any of these R's, any of them. I can even take that off, right there. Right? Any of those will work. What you need is something that you know the coordinates of. Well, I probably don't know the coordinates of this point or that, but I may know the coordinates along here. Whatever this x value is from here to here, I would know. So if you look, here's the equation. R cross F. By definition, we saw this in the vector algebra. It's equal to F times R times the angle in between, sine of the angle in between. Well, there's the angle in between the R and the F. I'm going to look at this and say, hey, by the way, if I were to do the perpendicular distance, this would form a right triangle. If I say sine of theta, so if I come in and say sine of theta in this diagram, that's going to be opposite d over the hypotenuse, which happens to be r. So d is equal to r sine theta. Agreed? That's just from Sukatoa. Well, guess what? In my definition, I have an r sine theta. So another way of expressing moment, besides saying r cross f, it's f times the perpendicular distance from the line of action of the force to the moment center. That's why we say force times distance, where distance is the perpendicular distance. So I got two ways to calculate a moment. I either go r cross f, and I usually don't do r cross f unless I'm in 3D. Or I do force times distance, where distance is the perpendicular distance. Yeah? I'm not saying anything that's not in the videos. How many have seen the video? Those of you that haven't, this is the first time you've seen it. This is all in the video. So if you're not taking any notes, don't worry. You can go see the videos and check out all these notes that I'm putting up there. Now, force times distance gives me magnitude. It's a vector. I need directional sense. Well, in 2D, I'm either going to be clockwise or I'm going to be counterclockwise. That's it. I can't have any other directions in 2D. Clockwise or counterclockwise. What is standard positive? Standard positive is counterclockwise. Why? Because it obeys the right-hand rule. Here's my x, here's my y, z's coming out at you. I start at x, I curl my fingers to the y, my thumb points to the z, but what type of motion is this? That's counterclockwise. So the standard positive is counterclockwise. I'm going to tell you, it doesn't fucking matter. Did I get that across with the F word? It doesn't matter. You can make clockwise positive, you can make counterclockwise. It doesn't matter. Okay? As long as you're consistent, it don't matter. Give you an example. There's an example in the book or in the video that says this. I'm going to put it up here so we can see it together. This is the example. So I've got 10 pounds, 20 pounds. Here's my moment center. 30 pounds, 40 pounds. There's 2 feet in between. I'm going to find what is the moment being generated by these 4 forces at O. Okay? And I'm going to do it 2 ways. I'm going to sum moments clockwise, and I'm going to sum moments counterclockwise. You're going to see it comes out to the same shit. So I'm going to say sum moments about O, and I'm going to take clockwise first. You with me? So this is going to be, let's go with this one first. 10, that's the force. What's the distance from 10 to O perpendicular wise? 4. That's how simple it is. 10 times 4 gives me the magnitude of the moment. Now you gotta come up with the sign. It's either positive or negative, depending on what you see. So I chose clockwise positive. Is this generating a clockwise moment at O? Well, how do I know? Take your pen. There it is right there. You with me? Follow it around O in a natural way. What is that? Counterclockwise. Well then, I should put a negative sign on that. What is a unnatural way? This is an unnatural way around it. That makes no sense. If you want to think of it differently, let's say that's the beam and there's O, where my index finger is. I push down this way. Which way is this sucker turning? Counterclockwise. Okay? Next, I know this is 20 times 2. 20 times 2 gets me there. There's the force. There's the distance. I gotta have a sign. I'm going to now move this to here. What allows me to do that? What? Say it louder, I can't hear you. Correct. Transmissibility says I can move this force anywhere along its line of action. So I can move it down to here if I wanted to. Now, I'm going to take my pen and at the arrow go around O in a natural order. What is that? Clockwise, positive. Next, 30 times 2, that's the force, that's the distance. Take your pen and arrow and go around O in a natural way. What do you got? Clockwise, positive. 40 times 4, its distance from here to here is 2 plus 2, 4. And if I take my arrow and go around, what do I get? Clockwise. So this is moments equal to a positive 2 to O foot-pounds. Well, positive means what direction? Clockwise. So I know this is a 220 foot-pounds clockwise moment. Anybody not understand what I just did? Because you're going to have to do this for problems. Yes? Now let's do it again, except this time, let's do it with some of the moments counterclockwise. So same problem. 10, 20, here's O, here's 30, here's 40. 2, 2, 2, 2. Some moments about O, this time counterclockwise positive. Again, this is 10 times 4, the distance from here to here, 4. Take the arrow, go around O, what do you get? Counterclockwise. Well, that's positive, so I'm going to put a positive here. 20 times 2, move this to here by principal transfer. Go around O, what is that? Clockwise, negative. 30 times 2, take this arrow, go around O, that is clockwise, negative. 40 times 4, go around O, clockwise, negative. So my moment about O is a negative 2 to O, pounds, feet, or foot, pounds, whatever way you want to write it. What the hell's the difference? In one I got a positive and the other got a negative. But when I got the negative, I said counterclockwise. Well, what's the opposite of counterclockwise? Moment about O is 2 to O, clockwise. Same damn answer. So does it matter if I choose clockwise or counterclockwise? No, it doesn't matter. Standard is counterclockwise positive. So probably Hibby decides when he does problems, counterclockwise is what I'm going to use for moments. And I'm telling you, You don't need to do that. You can have clockwise or counterclockwise as long as you're consistent. Got it? Who don't got it? All right. Moving on. Let's put up some facts. Here comes a fact. Fact number 1. Hey, forces on particles create no moments. Why? ¿Por qué? Will you Spanish speaking people? What is it? Why? There's that stupid why. Nora keeps asking why. Fuck him. I don't care about why. Right? I care about why, and you should care about why, because the person who knows why will become the boss of the person who knows how. Got it? Why?
Because it's perfectly good at distance r equals 0.
There is no distance. Everything comes to a single point. There are no distances. If there's no distances, there's no moment. There's no force, there's no moment. All right, number 2, principle of moments. One of our 12 concepts in this lab, also known as Varignon's theorem. Varignon said, hey, it doesn't matter whether you take the force or you take the components of the force, the x and y components, and find the moments using the component. If it's easier, go ahead and do it. You get the same result. So sometimes it's hard to find, not hard, but you have to do more work to find the perpendicular distance. You don't have to by Varignon's theorem. Just break the force into its components, use the components to find the moment. Number 3, moments of a force about a point is 0. If, of course, there's a trivial case, force is 0. Oh, if there's a force 0, I ain't worried about a moment. Number 2, force is parallel to the axis. And the big one that comes into play when you solve problems, when the line of action of the force goes through my moment center, that force creates no moment. You with me? I'll give you an example of basically these two in action. Varignon's theorem and C. So I have this force of 100 pounds. I want to know what the moment is over here at O. Great. If I don't use the components, then I need to take this force and find actually the perpendicular distance from the line of action of the force to O. That's just geometry, trig, whatever it takes to find angles and distances. Usually it's SOHCAHTOA, right? Because usually you have the right triangle. Now, if I don't want to go through the hassle of finding this D, I can use Varignon's theorem and say, okay, this is 100 cosine 30, this is 100 sine 30. Agreed? Those are the components. Well, guess what? This component right here goes through the moment center. That sucker creates no moment. What am I left with? 100 sine 30 times the distance of 5. That's it. So my moment is 100 sine 30 times 5. And if I move it to here by the principle of transmissibility and go around O, that is counterclockwise, as you see CCW. Yes? So you just saw Varignon's theorem in action, and you saw, hey, when a force goes through the moment center, it creates no moment. Now, if you really look at it real close, what is this distance D? That's 30 right here. Sine 30 is equal to opposite D over 5. So really D is 5 sine 30. Agreed? 5 sine 30. Just that right there. That is D. So you actually find D when you do the components. But it's much easier. I didn't have to go through that. I just broke it down and said, oh, this distance times 5 is what I need. Okay? Questions? Thoughts? Comments? Ideas? Anything bothering anybody? Yeah?
So we use 5 times sine 30, that's 5 times 1 half. So then you multiply the 2.5 by 100, and then you get the 250 pounds.
That's it. Easy. All right, that said, let's do some problems. First problem I want you to turn to do is this one. I'm going to skip around, but I want to get this in right away. Too sweet. So page 53, por favor. Por favor. And you say, well, why do you want to get this one in right away? Well, it's easy. And the reason I want to get this in is because, hey, remember this problem down here? This was question number 2, old test question. What the hell do you see here? A pole with a force and a force, correct? And you're going to see the same problem in the textbook, and you should try it in the textbook. But that's what I'm showing right here. So think about this. Nora's an asshole. He loves to fail people. His tests are from hell. Let's see. Let's break this down. Did Nora show you how to do a pulley problem? Did Nora show you how to deal with a block attached to a spring on an incline? Did Nora show you how to do an equilibrium 2D problem? Nora's about to show you how to deal with a pole attached to 2 cables, and you're going to find the moment about G. So probably on this test, I didn't say find me the moment about G. I said, hey, the moment about G is, and I gave some number, 0, 300, whatever. Why did I do that? Well, because I know you can get this force of 150 here. What I need is that force here so I can find that cable and that cable. Once I find that cable, then I can swing back and get all these. That's why. So I probably gave, hey, the moment of G, let's just say, is 0. That allows you to find dB. Now, knowing this, there's 2 unknowns. I can draw a free body diagram of that joint, some force X, some force Y, bang, bang, get these 2 values. Which means I now have that value. Which means now I can isolate this because we did a problem just like that, right? In class, block on an incline, attached to a spring. And you know damn well I can take all these 3 springs, make them into 1 spring. Correct? So where is it that I'm trying to fail your asses? Where is it that I'm trying to fail you? Oh, Norris says he wants to fail everybody. Some of the things I read about what I do, you're like, oh, what the fuck? Where are they getting this shit from? You tell me, a teacher you have in engineering that's giving you 7 sample tests with solutions. That may give you 1, maybe 2 tops. I've given you 7. But I'm not the failure. Oh, he's a prick. Really? Really? Testing man. Here we go. Look, question number 2. I'm not hiding anything, man. I'm telling you what I'm going to do. Oh, look at this. A fucking pole with 2 cables. Let's see, I bet it says, hey, the moment at the base of point C is 300 Newton meter. Wow. If I tell you the base is here, that means I should be able to find BA. Shouldn't I? Let's see. Things that make you go, Oh, here's another one. Question number 2. Oh, it's not a pole. Forget everything. It's a T. What the hell's the difference? There ain't no difference. I got 1, 2, 3, 4, 5 forces. Well, probably I should be able to do the pulley and get T3, which means what's unknown is T2. Well, if T2 is unknown and he gives me the moment ago, I can find T2. Oh, does he give me the moment? Oh, the moment ago is 0. So I gave you the moment. That should allow you to find T2. By the way, the 300 line of action goes through, that's creating no moment. And I did it on purpose. I made a force go through the moment there to see if you would incorporate that in your moment equation. Because we know it doesn't create a moment. Let's see. Is there anything here that we have not discussed? Do you know how to do pulleys? Yeah. Do you know how to find a moment? Well, we're doing moments right now. Do you know how to do a block on an incline? Yeah. Do you know how to do springs and parallel? Well, you should. Whether you do or not, that's up to you. But I know I can sleep well enough because I know I covered it in class. So what part of this says to you, oh my God, he's trying to fail? What part of this says I'm trying to fail? Because there ain't nothing here that I have not discussed or will be discussing because I'm gonna do more moments here shortly, right? But yet, I'm the asshole. Really? I just don't understand sometimes when I read these comments. And sometimes when I get bored, I do read comments. But I'm like, huh? How? Nora never answers any questions in class. What the fuck are you talking about? Have I not answered any of your questions? Then I don't understand that response. I don't understand that response. Oh, you're pissed off at me because you got a 30 on the first test. That ain't my fault. That's your fault. Because I promise you, there isn't anything on the test that I have not covered in class. In one form or another. Now, whether you got it or not, that's a whole different ballgame. I cannot control that. Whether you did your 5 problems or not, I can't control that. I've recommended. It's up to you. You're a grown adult, supposedly. Supposedly. Some of you don't act like grown adults. Just saying. Yes, my son.
On your like comment on like read my professor, right? What do you think is like the most notorious question in the test? Is it like question 2?
Usually.
Okay.
You know? Usually, question number 2 is the most notorious of the bunch. What? There's some that are pretty atrocious. Yeah. I should be high. I always aim to be the number 1 dog. I want to be the best at what I do. I don't settle. It's not my job. That's not my thinking. I want to be the best professor on this fucking campus. It doesn't matter if it's engineering or chemistry or political science or whatever. I want to be number 1. That's my goal. That's a pretty damn good goal, right? And you know what? You need to be number 1. I want to be the number 1 engineer in my company. That's what you should be thinking. I want them to want me to stay. When I say I'm leaving, no, please don't go! We'll give you $10,000 more. No, make it 15. And I'll stay. What?
Is there a difference between moments and torque?
No. For engineers, usually torque means something that's already spinning. You know? There's this building, it ain't spinning, but there's moments on it. There's constant moments that are adjusted due to forces on this building. And usually in my mind, I think of torque as something that is already spinning in some fashion. You know what I'm saying? That's what I'm thinking. All right, free body diagram, first and foremost. This is just like the problem in the test that I showed you. So my free body diagram, and remember, it's rigid body now. I don't get the luxury of everything going to the same concurrent point. It don't. Here's O. I have this force here, which I'm going to call TAB. I have this force here, which is TCD. This angle here is 60. Why? Because that's 60, which makes this 60, alternate interior angles. This is 70. That has to be 70, so I draw a line here. That's 70. Now, to find the moment here, I need to find this freaking perpendicular distance. I don't want to do that. What do? I say, hey, Varignon, please come to my assistance. What does Varignon say? Hey, go in there and break those forces into components. Okay, let me do that. I have a component here, which I'm going to say is TAB cosine 60, and a TAB sine 60. I'm going to have a force here, TCD cosine 70, and a force here, TCD sine 70. Clearly, nope and nope. Those sine components are going through O, they're creating no moment. They're creating no moment. Everybody with me? So there's only two forces creating a moment. Okay, let's write out what the two damn forces are. Some moments about O. You pick clockwise or counterclockwise. I'm going to go against the grain because that's my damn nature. I always go against the grain. In faculty meetings, they say, hey, let's vote on this. And there's 25 of us. 24 vote for this, and I'm the only one that said, nope. I do not follow. Especially when it comes to students. Hey, we need to put more labs. And I'm thinking to myself, what would students think? Fuck no, I don't want to do lab. That's 2 hours in the lab, plus another 2 hours to write up the fucking lab for one fucking credit. You think students want to do lab? No. So when they say, let's put another lab, I'm like, nope. Because I'm thinking about what the students would want. Students don't want lab. How many want lab? Raise your hand. You want lab. You're the only one. I hated labs when I was in your shoes. It's like, I'm putting all this work and you're giving me one credit? Screw this shit. So I'm always contrary. I always take the opposite approach. So I'm taking the opposite of standard. That's equal to force, TAB cosine 60. That is the force. Times its distance. What's its distance from here to here? Well, it looks like it's 10 plus 15. That's 25. I need a sine. Let's move this to here like so. And I'll go around O. What do I see? That's clockwise. Hey, hey, positive. Next, I'm going to say TCD cosine 70. That's the force. I need the distance. The distance from here to here is 15. Now, let's move this guy all the way back to here and go around O. What do I get? Counterclockwise. Oh shit, that's a negative. That's 8750 minus 2565 moment about O is equal to 6185 positive. So this is pounds, feet, clockwise. So these moments are trying to pull this sucker clockwise. So if it's going to go, it's going to rotate clockwise as it falls. Now, if it's to stay there, what must the ground do? It must create a 6,105 pound force, pound-feet, that is counterclockwise for it to stay put. If I don't produce that, then you'll see the sucker go this way. What? Maybe you should get new glasses. I want to see if I can see it. 6185 clockwise. Yeah, I can see it. You can't see it. Can you? You're blurry? Time to go to the optometrist. You just did it. He fucked you over. Go get a refund. Okay. Let me zoom in for her. I'm sure you're not the only one. I'm sure the person way in the hell in the back who's looking at his phone can't see it anyway. All right. Next problem. You ready? Here we go. Are we good? Any questions on how to do this moment? Next problem. Can I borrow a pen? A ruler? A ruler. I'll take that. That's good. Anybody got a ruler? Can you grab that ruler? Gracias. So, I have this. Damn, this is a fucked up ruler. I have this. Here's this force. Now, if I want to find the moment of this force about A, what I'm going to need, here's A, I'm going to need this perpendicular distance. Okay? Here's the ruler back. I'm going to need that perpendicular distance. And I'm like, oh, crap, I got to do all that geometry and tricks. I don't want to do all that. So, Ferdinand to the rescue. Here we go. We're going to say, screw that finding that distance. I'm going to say there's an x component of this and a y component of this. This is going to be 300 cosine 30. That's going to be 300 sine 30. Again, this is like saying this. Head to tail. I can put it here or I can put it there. I'm going to put it there. Over here, I can say there's an x and a y. This is going to be 200 cosine 20. This is 200 sine 20. What did I say? Oh, 300. Shit. 500. My bad. At least somebody's awake. I wasn't. Please note,
Wait, where did it say 500?
that guy and that guy are creating no moment about A. Why? There's that stupid Y again. Y,
Oh, that's right.
the line of action goes through your moment center. There is no D. Great. So I really have only 3 terms. So I'm going to say some moments about A, and I'm going to take counterclockwise. Notice the first time I did clockwise, and I'm doing counterclockwise. It doesn't matter. You can do whatever the hell you want. That's equal to 300 cosine 30. What? Yep. There's the force. I need a distance. There's the distance D. Okay, now, I'm going to move this, of course, by the principle of transmissibility to here. This is still 300 cosine 30. Agree? Well, God damn it, why do I keep saying 300? 300's on my mind. Did my test question have 300 on it? Yeah, I'm already making up your test number 1. Question number 1 is done. I'm working currently on question number 2. By the way, there's pulleys, there's blocks on inclines, there's springs, there's a moment,
There's everything.
and I'm not done yet. I'm still working on
Wait, there's a moment.
it. Yeah, you know it. She's like, oh, fuck. What's that?
Whenever I have a drawing,
Yeah?
your little portrait, make sure that's sitting on the ground. In your lap, you just do like this.
What portrait?
You have a little picture outside the sleeve. Like the board right before you go into the swim.
Well, that distance is 3.5 plus 0.5. That's El Cuatro. 4 for you non-Spanish speaking people. Now, tell me, clockwise or counterclockwise, take the arrow and your pen and go around A. What is that? That's a big old negative on that one. Then I'm going to do 500 sine 30 times its distance. Well, if I move this sucker all the way down to here, right? Its distance from here to here is 12 for you Spanish-speaking people. And this is creating a, what is this? Counterclockwise, that's a positive. Again, that's the force, that's the distance. That's the force, that's the distance. And then I'm going to do 200 cosine 20. There's the force. I need a distance from here to here. That's also 12. Now that going around A is counterclockwise, positive. If I sum all this, moment about A is 3523.21 pounds, feet, counterclockwise. Done. You with me? Who's not with me? Speak or forever hold your peace. Yes! That's question number 2 for the day. I'm going to cut you off here shortly. It's like alcohol. Can't have enough. Go ahead. Yeah, it's always going to be your fault. Okay. So if this is the beam and I'm pushing, right? Here's this, it's kind of hard. So here's the beam. Let's do this one. I'm here and I'm pushing. This is A, my finger, index finger, and this is the 200 cosine 20. What's this doing when I push? That's doing counterclockwise, ain't it? Why? Why? Next problem. Oh, I see pulleys. You know what I'm going to do? I'm going to go B. So for me, all this is bullshit. No! We're moving on, dude. What is it that you need? What you need? What you need? Going once, going twice. I don't understand why you need to take pictures of this because there's a video on it. It'll open up this Friday. Good God Almighty. But you can take a picture. What? Pull it out of my ass. Which fork? That fork? What's the distance from here to here? 3.5 plus 0.5 is 4, I think. Last time I checked my addition. Yeah? Next question. Here we go. Again, I don't care about anything other than the pulley. If I look at this and I say that's P, let's call it T. That's T, that's T. This is 200, that's 200. So if I isolate this right here, I'm going to get this pulley to look like this as a free body diagram. T, oh, sorry, 200, 200, T, and downward is going to be 800. 200 T, 200, 200 T, 200, some forces in the Y equals 0, positive up. That's 200 plus T plus 200 is equal to 800. Another way of looking at it is to say, hey, the ups must equal the downs. That's really what you're saying. Or the lefts must equal to the rights. That's equilibrium. If I solve this, you know what MT is. It's 400 pounds. So as far as I'm concerned, you can get rid of this stuff and just look at this here. So now I'm going to isolate this by itself. My free body diagram here is going to look like this. I have a force P, angle 30 degrees. This is 5 feet. This angle here is 60. And I have a cable tension of 400 pounds. Sitting out here, which is 7.5 inches away from A. Okay? You with me? Who's not with me? It says here, hey, the moment of O is 0. About O. So I'm going to sum moments about O. Can I take clockwise or counterclockwise? Which one? Doesn't matter. I'm going to choose clockwise because I like being opposite to standard, which is counterclockwise. Sum of the moments is equal to, well, what do I got? Well, this guy has a component this way, P cosine 30, and a P sine 30. Yes? So I'm going to say P cosine 30. That's the force. I need a distance. Well, if you look real closely, this is 5 feet, that's 60. This will be dy, and this will be dx. This is really going to be dy. dy is going to be sine of 60 is equal to dy over 5. dy is equal to 5 sine 60. That's going to be 5 sine 60. I need a sine. Well, this guy's over here, so I can move it all the way over here by principle of transmit and go around O. Here's O. Going around O, what do I have? That's clockwise. I chose positive clockwise, so that's a positive. P sine 30. That's the force. I need a distance. This is dx. Because I need this distance now from here to the line of action of the force. That would be dx. Cosine 60 is equal to dx over 5. dx is 5 cosine 60. So this should be 5 cosine 60. Positive or negative? Well, if I follow the arrow around O, what do I get? Clockwise, positive. Then I have to have the 400 times, it is 7.5 divided by 12. 12 is my CF conversion factor. Please note, those are 7.5 inches. Everything else is in feet. The 5 is in feet. I can't have 5 feet and 7.5 inches. I ain't going to get the right answer. So I got to convert And I did. There's the force, there's the distance. Positive or negative? Well, if I move this along its line of action and go around O, what is that? Counterclockwise. Damn it, that's negative, and that must equal 0. So you can solve for P. P is equal to 50 at an angle of 60 degrees.
Yeah, that's it.
You with me? Who ain't with me? Speak or forever hold your peace. Yes or no? Howdy ho. What? You good? Oh, I thought you were raising your hand for a question. Everybody good? What?